I am delighted to welcome all of you to today's session on AICT Atal Faculty Development Program on Design, Development and Optimization of Electric Vehicles for a Green Future, which was organized by School of Electrical Engineering, Sri Vaishno Devi University. Today we are privileged to hosting Professor Ghanshyam Singh sir, professor at University of Johannesburg, who will be sharing his expertise on the topic of impact of Industry 5.0 for sustainable and resilient manufacturing of electric vehicles and related technologies. So I request our student Anushka, please give the brief introduction on our today's expert. Yeah.
Good evening, everyone. We are honored to welcome Professor Ghanshyam Singh from the University of Johannesburg, South Africa. He serves as a professor in the Department of Electrical and Electronic Engineering Sciences and director of the Center for Smart Information and Communication Systems. Professor Singh completed his PhD in Electronics Engineering from IIT BHU Varanasi and has over 20 years of academic and research experience. His expertise lies in RF, microwave and terahertz antennas, next generation communication systems, radio resource management, and sustainable smart technologies. He has authored over 200 research papers, supervised numerous doctorals and master's theses, and contributed to books with publishers like Springer, Wiley, and many more. His research also focuses on sustainable smart city solutions, Industry 4.0 and 5.0 technologies, and energy efficient resource management. With this rich background, Professor Singh will be sharing his insights on the topic Impact of Industry 5.0 for Sustainable and Resilient Manufacturing of EVs and Related Technologies. Please join me in welcoming Professor Ghanshyam Singh.
Thank you, Anushka. Ghanshyam sir,
Yeah.
yeah,
Okay,
I am
thank you,
handing over
Anushka,
to you,
and
sir.
thank you, Jatin, for
Thank you so much, sir.
inviting me. It's interesting. Let us see, let's and discuss something new. So, okay. So, is it visible?
Yes, sir, it's visible, sir. Sir, can you please make it in a slideshow mode, sir?
Yeah, sure. Now, is it
Thank you,
okay?
sir. Yeah, perfect.
Okay.
Okay, sir. Thank you so much, sir. Thank you.
Yeah. So, good evening to everyone, and thank you, Jatin and Professor Kumud Ranjan for inviting me on this very interesting topic. That's impact of Industry 5.0 for sustainable and resilient manufacturing of electric vehicles and related technologies. So yeah, definitely it is a very interesting and demanding uh, research areas, research problems. So before coming on this one, actually, I would like to discuss something. What about the motivation behind this one? Electric vehicles. And then this sustainable and resilient. And in this context, what should be the role of Industry 5.0? Already we have Industry 4.0. And but then why are we looking Industry 5.0? How this Industry 5.0 is different from Industry 4.0? So we will go through this one. So you know, it is well known that this technology, engineering sector, it contributes a very significant amount in our GDP. How it contribute in our GDP? By productivity, increasing productivity, creativity, establishing new industries and markets, further increasing efficiency of our production, even in existing industries. So this technological transformation is very crucial parameter which contribute to our GDP. So with this context, what are the way just boost our GDP? So increase the productivity, manufacturing industry, new industry and business model. It is very important. New industry establish new setup as well as new business model. That's important. Enhance efficiency, expand markets, innovation and competition. Whatever the competition in the market, create a skill job and drive industrialization. So this industrialization is important from industry 1, industry 2, industry 3.0, industry 4.0, and now we are talking industry 5.0 or 5.0. So, and then with this context, what should be the market prediction of automobile sector, automotive industry? So when we will see this our market intelligence, then according to the market intelligence data, this forecast of automotive market up to 2030 is approximately 38.45 billion US dollar, as compared to this current in 2025, approximately it is 18.83 US billion dollar, right? So significant amount of enhancement has been predicted next 5 years. So this one is very interesting sector. In this direction, develop some business model. As you know, this one is, as a academician, how should contribute in this sector. So with this context, a business model, some new ideas. Uh, so with context of industry, generally we have to sell new ideas. That should be an interesting concept. As a academician, we should contribute in our GDP. So with this talk, generally we try to focus on the industry 5.0, industry 5.0. It's a brief introduction. What exactly is it? Potential features of industry 5.0, differences from industry 4.0 and 5.0. How this industry 5.0 is better than industry 4.0. Industry 5.0, its potentials, challenges and future direction and enabling technology. Then we come over this second part of this talk, that is role of industry 5.0 for e-vehicles, electric vehicles, and key contribution of industry 5.0 to e-vehicles. And then we try to find out answer a few questions like, how does industry 5.0 impact the manufacturing process of e-vehicles? What are the potential advancement in e-vehicle technology due to industry 5.0? And how does the industry 5.0 influence the integration of smart technology in electric vehicles? So we try to find out the answer of these questions from this discussion. And then integration of smart technology into electric vehicles within industry 5.0. And then finally, key challenges in integrating smart technology into e-vehicles in the context of industry 5.0. And then finally try to conclude the lecture. So now come over the industrial revolution. So as we know, this our industrial revolution, industry 1.0, Industry 2.0, Industry 3.0, Industry 4.0. So actually this Industry 1.0, it was uh, conducted by this, steam-based machine, mechanization in Industry 1.0. Then when will come Industry 2.0, then electrification has been introduced. So this electrical energy based mass production has been included in this our Industry 2.0. In Industry 3.0, actually this one, computer and internet based knowledge has been included. So automation has been incorporated in Industry 3.0. And in Industry 3.0 and Industry 4.0, this AI also included. Generally this Industry 4.0, that's digitalization, Internet of Things, cyber physical systems, digital platform, product service systems, and networks has been involved in this our Industry 4.0. That's a digitalization. But still, there is some challenges. We will discuss what are the challenges in the Industry 5.0. So definitely it produce enhance the productivity, mass production, but there are several challenges. So one by one we will come, and then this up to 2022, the concept of Industry 5.0 has been explored, and in this with this context, personalization and humanization has been involved. So this personalization and humanization, how is it and what is its impact? So generally with this context, in Industry 5.0, this personalization, this means mass customization, and then cooperation between man and machine, physical cognitive system. In Industry 4.0, there was cyber physical system, CPS, but here cyber physical cognitive system, sustainability concept has been included in this Industry 5.0, and then human centric systems, resilience systems. So this Industry 5.0, it has a drastic transformation as compared to Industry 4.0. We further discuss one by one in these slides. So Industry 5.0 will completely change how companies work in the next 10 years. It will no longer only be about automating and optimization process, but also about caring peoples, their workers, users, and make their lives easier, more productive, and more meaningful. Industry 5.0 is new era in an industrial revolution which aims to integrate artificial intelligence, automation, robotic technology into manufacturing production process, while enabling workers to play an active role in decision making. So in this one, Industry 5.0, collaboration between machine and human being is very important parameters. So now let us define this Industry 5.0. So Industry 5.0 represent the next phase in industrial evolution, focusing on the integration of advanced technologies with human-centric approaches to enhance manufacturing process. This new paradigm emphasizes on mainly 3 points. That's human-machine collaboration, customization, sustainability. So this the use of cutting edge technologies such as artificial intelligence, machine learning, internet of things, even internet of everything, and digital twins. So these basic principles of industry 5.0. Industry 5.0 represents the next stage of industrialization, integrating advanced technologies while human expertise and creativity to achieve more personalized, customized, sustainable, and resilient product processes. The key principles difference from industry 4.0, potential challenges and implication we should discuss one by one. So it's this first approach is human centric approach. With this context, industry 5.0 emphasize human machine collaboration. So later we define that's cobot, human robot, and then it will form cobot, with talent being the core of industrial operation and to serve human better rather than replacing them. So if this one industry 5.0, it also enhance the involvement of our human being in industry. So the problem of job unemployment will reduce as compared to industry 4.0. Sustainability. The industry 5.0 focuses on economic, environmental, social, and technological sustainability with new requirement and development direction for sustainability. Resilience. The concept of resilience in Industry 5.0 involves the seamless integration of technology and society into the process of economic development, aiming to strengthen industrial resilience and competitiveness. So this potential feature of Industry 5.0, human machine collaboration, as we discussed, unlike Industry 4.0, which focus primarily on automation and digitalization, Industry 5.0 aims to create harmonious relationship between the humans and machines. This collaboration leverages human creativity and problem solving skill alongside the precision and efficiency of the machine. Customization and flexibility. Industry 5.0 enables the production of highly customized product to meet specific consumer needs. This one will provide means demand of individual how to fulfill. This is achieved through advanced manufacturing technique and flexible production systems. So this human machine collaboration, customization and flexibility, and then sustainability. A significant focus of the industry 5.0 is on sustainable manufacturing practices. This includes reducing waste, improving energy efficiency, and promoting environment friendly production method. And then involvement of advanced technology, the integration of artificial intelligence, machine learning, intelligent of internet of things, even internet of everything, digital twins, collaborative robotics is essential to industry 5.0. These technologies enhance production efficiency, enable real-time data analysis, and support intelligent decision making. So the difference between industry 4.0 and industry 5.0. So industry 5.0 differ from the industry 4.0 by replacing a stronger emphasis on human centric sustainability and resilience. So with context to industry 4.0, focus on connecting machines. However, the industry 5.0 focus on delivering customer experience. 4.0 mass customization, whereas industry 5.0 it talk about hyper customization. Industry 4.0 intelligent supply chain, whereas industry 5.0 responsive and distributed supply chain. Industry 4.0 is smart product, whereas Industry 5.0 experience activated product. Industry 4.0 manpower distance from the factories, whereas Industry 5.0 return of manpower to the factory. So this will also sort out our unemployment problems. So the Industry 5.0, it integrates people and machine into the production to achieve more personalized, sustainable, and resilient development as opposed to the primarily technology-centric approach of Industry 4.0. To understand the key difference between Industry 4.0 and 5.0, it is essential to explore their core principles, goal, and technology approach, which has been discussed here. So core principles and goal of industry 4.0. So this industry 4.0 technology driven focus on the integration of advanced technologies such as cyber physical systems, internet of things, big data analytics, automation to optimize production process and improve efficiency and productivity. Automation and efficiency with this context emphasize on machine to machine interaction and data driven strategy to enhance productivity and efficiency. With context to digitalization, the it emphasizes centers around the digital transformation of manufacturing process, creating smart factories with interconnected systems. When we will talk about the industry 5.0, 5.0, it's value driven. Shift the focus from technology to human centric values, emphasizing sustainability, resilience, and well being of the stakeholders. Human machine collaboration prioritize the synergy between human creativity, critical thinking, and advanced technologies such as artificial intelligence, robotics to create more personalized, efficient, and sustainable production process. Sustainability and social responsibility, which aims to create a sustainable and socially responsible industrial ecosystem aligning with global goals such as those set by the United Nations sustainability goals. That's there are 17 points in with the context of sustainability. So this industry fulfill that sustainability goal. So technological approach in industry 4.0, advanced technologies utilizing IoT, AI, big data, and cyber physical system to automate and optimize manufacturing process. And then smart factories focus on creating interconnects and intelligent manufacturing system that can operate autonomously. How this technologically industry 5.0 differ from industry 4.0? Then industry 5.0 emphasize on human centric technology, integrate human ingenuity with intelligent machinery, emphasizing human machine collaboration to enhance production quality and work environment. This means robot and human robot collaboration. So that term has been defined is cobot, collaborative robots. So use cobot to work alongside humans, enhancing their capability and ensuring more adaptive and responsive production systems. So it is very important when we will talk about this collaborative robots, cobots, then how we should develop, and then what type of collaboration, how to write protocols. So various R&D is existing there. And then sustainable practices incorporate environment friendly production techniques and aim to reduce the ecological footprint of industrial activity. So technological innovation with context to industry 5.0. So artificial intelligence, AI play a crucial role in automating tasks, optimizing production process, and enabling predictive maintenance. It also supports human worker by providing real-time insights and decision-making assistance. So then AI, and after that collaborative robots, that's cobots. Robots in Industry 5.0 are designed to work alongside humans, assisting with physically demanding tasks and improving overall productivity and efficiency. Internet of Things, IoT devices facilitate seamless communication between the machine and human, enabling better monitoring and control of manufacturing process. And then next one is digital twin. These virtual replica of physical systems allow for simulation and optimization of production process, leading to improved efficiency and reduce downtime. Potential challenges in implementing Industry 5.0. So, with this context, implementing Industry 5.0 technologies requiring significant investment in infrastructure and training. There are also concerns related to the data privacy, cyber security, and potential job displacement. So technology adoption, implementing Industry 5.0 poses challenges in effectively introducing new technologies to feed production lines and gaining full acceptance of these technology by workers. So time to time, workers training is also very important with this context. Cyber security issue, it's a growing concern. Growing connection creates new cybersecurity issues such as data breaches and virus assaults. Environmental impact, Industry 5.0 aim to reduce carbon emission and promote sustainable manufacturing practices, which presents challenges in achieving environmental sustainability throughout the implementation process. Workforce adoption, the transition to Industry 5.0 may lead to job displacement and may require the adoption of workforce skill to align with the technological advancement. That's very important. Posing challenges for the labor market. Opportunities, what are the research opportunities? Industry 5.0 offer numerous benefits including increased production efficiency, enhanced product quality, and ability to meet specific consumer demands. It also promotes sustainable practices and supports economic growth through innovation. So this Industry 5.0 overall very important for our economic growth. So Industry 5.0, with this context, networking and integration, so big data, Internet of Things, and sustainable development, sustainable manufacturing, and human-centric approach, human expertise, human-robot collaboration, and then technological advancement. This means robotics, machine learning, artificial intelligence. All these technology should involve there. So Industry 5.0, it's a potentials, challenges, and future direction, and enabling technology. So when we will talk about the enabling technology, so there are various factors, various components When we should start with this artificial intelligence. So, with the context of artificial intelligence, intelligent automation, greater efficiency, quality control, and quick decision making, which will contribute in our industrial transformation, Industry 5.0. And then cobot, this cobot increase productivity, robustness, enhanced dexterity, more consistent and accurate. 6G technology, 6G and beyond 6G. This means 5G, beyond 5G and 6G technology. So knowledge discovery, smart resource management, low latency, ultra high reliability. So this one is also very important component of our industry 5.0. Digital twins, with this context, reduce cost. That is very important. Whatever our product, how should reduce their cost. So it will be available for everyone in our society. Predicting future errors, design customization, predictive maintenance. And then this blockchain technology, that is uh, a component of our DLT, digital ledger technology, that is used for our security purpose. So decentralized management, operational transparency, create digital identities, and compartmentalize approach. It overall improve the our security. Then Internet of Everything's. Now we are talking this IoT, but now this in when beyond 5G and 6G will implement it, then we will try to introduce Internet of Everything's. And with this context, assets productivity, cost reduction, supply chain and logistic management, reflect intelligence in networks. Then next component is big data, data analytics, customization, faster and better decision making, faster competitive pricing, real time forecasting. So that should be very useful with our industry 5.0. And then another one is very important technology, that's computing technology. So edge computing, which will edge computing, fog computing, cloud computing, whatever. And even though then after that, this our what we say, quantum technology, quantum computing, quantum communication, and quantum sensing could be involved in this one. So, with context to this computing technology, target is that lower latency, increased cyber security, expanded interoperability, and reduce storage cost. So, these are the concern with enabling technology required for our industry 5.0. And then we will come over this its potential. So here's very few are written. It has huge potentials. So digital drugs, this means healthcare industry, smart factories, green economy, smart fashions, intelligent traffic, and innovation ecosystems, this personalized healthcare. So these are a few one. It has a lot of potentials with context to industry. When we will see any industry, it will be industry 5.0 contribute too much. And then what are the potential challenges? So with this context, suppose human robot co-working, how they jointly work. So that's very important. And their protocols, algorithms, how it should need to write. And then scalability, from a small scale to large scale, how we scale up, scale down, and then AM scaling, privacy preservation, regulatory compliances. This means it is also very challenging task. This regulatory and standardization, government regulatory, how to standardize the product, and then skill workforce, time to time their training, and data security. So all these are a few industry 5.0 challenges. And then it also includes future direction with context to this quantum computing, quantum communication, and even quantum sensing. When this quantum computing, quantum communication, and quantum sensing, then we can talk about quantum IoT. Global industry standards, and then cognitive as human machine working policy standards and regulations, continuous training, and this blockchain, that's for our security purpose. So this one is the overall concern about the industry 5.0, its potential challenges, future directions, and enabling technologies. Now come over the role of industry 5.0 for e-vehicles. So with this context, you know, the industry 5.0 represents a significant evolution, emphasizing the integration of human creativity and machine efficiency to achieve sustainable and human-centric industrial process. This paradigm shift has profound implication for the electric vehicles sector, particularly in areas such as manufacturing, battery management, and supply chain optimization. So the industry 5.0 and electric vehicles, with this context, when we will come over the manufacturing process, so we should involve digital twin as their roles discussed in previous slides, human machine collaboration, and this electric vehicles battery production. So these are concerned with our manufacturing process. And then sustainability practices. With this context, environmental sustainability, circular economy is important component. And then come over the technologies. With this concern, big data analytics, blockchain technology, and artificial intelligence machine learning should be there. And when we will talk about this human-centric industry 5.0, the consistent focus on the human-centric approach in industry 5.0 highlights the integration of human skill and creativity with advanced technologies, which emphasize the importance of human machine collaboration, aiming to enhance productivity while ensuring social sustainability and workforce empowerment. And when we will talk about this one, then human centric approach in industry 5.0 will significantly enhance job satisfaction and productivity in manufacturing sectors. It also integration of the human skill with AI in Industry 5.0 will lead to innovative solution or complex industrial challenges. So this human centric Industry 5.0, it is very important with this e-vehicles. Second one, this one, e-vehicles and renewable energy integration. This interest, this interesting interest, integration of electric vehicle with renewable energy sources reflect a significant shift towards sustainability, which explore the potential of electric vehicles to contribute to a self-reliant energy ecosystem addressing both environmental and economic sustainability. And this integration of renewable energy sources with electric vehicles infrastructure will reduce the overall carbon footprint and transportation. Also, advancement in renewable energy technology will accelerate the adoption of electric vehicles globally. And then another one, this important technology, that's a digital twin. The application of digital twin technology in Industry 5.0 is gaining momentum, offering new way to enhance human-machine interaction and optimize industrial process. And this one, digital twin technology will revolutionize predictive maintenance and operational efficiency in manufacturing process. The use of digital twin will enhance the accuracy of effectiveness and human machine. Then another one, this when we will talk about this, our blockchain technology, blockchain and secure communication in Industry 5.0. The integration of blockchain technology and secure communication protocol in Industry 5.0 is an emerging critical research area. Due to this blockchain technology, blockchain will provides robust solution for data security and integrity in Industry 5.0 applications. Secure communication protocols will be essential for successful implementation of Industry 5.0. And then we will talk about this circular economy. This circular economy, novel theme of integrating circular economy principle with Industry 5.0 technologies highlights the potential of sustainable industrial practices, which explore advanced technologies which supports the recycling and remanufacturing of material, contributing to a more sustainable and resource efficient economy. This circular economy principle in Industry 5.0 will significantly reduce industrial waste and resource consumptions. Advanced technology in Industry 5.0 will enable efficient recycling and manufacturing process, promoting sustainability. So with this context, we discussed the role of Industry 5.0 for e-vehicles. And then human machine collaboration, advanced manufacturing. So when we will collaborate human machine, then it will improve the efficiency, reduce wastage, prioritize environmental sustainability. With context to advanced manufacturing, introduction of micro factory, that is very interesting concept, which allow for more flexible and lean manufacturing of electric vehicles, challenging the traditional monopolistic control of large original equipment manufacturers. This approach minimizes the ecological footprint and reduce total investment costs. Battery management and remanufacturing. So Industry 5.0 technologies such as digital twins, Internet of Everything, and blockchain are critical in optimizing remanufacturing process of lithium-ion batteries. These technology enhance diagnostics, accuracy, safe disassembly, and high quality reassembly, thereby improving efficiency and sustainability. Supply chain optimization, blockchain technology that should be used for supply chain optimization, sustainability and circular economy, which I have discussed, and challenges. What are the challenges with this context? Despite its potentials, the integration of Industry 5.0 in the electric vehicle sector faces several challenges, including immature technology providers, financial constraints, and regulatory hurdles. Government policy regulation and standardization. Overcoming these barriers require coordinated efforts from policymaker, manufacturer, and technology providers. So this is very challenging task when we will implement Industry 5.0 in electric vehicle sector. So policymaker, manufacturer, and technology providers, they must sit together and make their policies and standards. Now come over the these questions. How does Industry 5.0 impact the manufacturing process of electric vehicles? So with this context, Industry 5.0 is transforming the manufacturing process of electric vehicles by integrating advanced technologies and emphasizing the human machine collaboration. Here are key impacts. So this technology integration, sustainable practices, manufacturing innovation. So with context to technology integration, digital battery passport, data analytics, blockchain technology, remanufacturing with context to sustainability, remanufacturing, circular economy, and when we will talk about manufacturing innovation, so digital technologies, metal additive manufacturing, human machine collaboration. So with this context, this our human-centric manufacturing approach, as I discussed earlier. So human-centric approach in Industry 5.0 significantly improve worker satisfaction, productivity, and electric vehicle manufacturing. The integration of human-machine collaboration in Industry 5.0 lead to more sustainable and efficient manufacturing. Then another one, when we'll talk about artificial intelligence, then with this context, AI driven predictive modeling in Industry 5.0 enhance the efficiency and accuracy of electric vehicle manufacturing process. The integration of AI and machine learning in Industry 5.0 lead to significant advancement in the customization and personalization of electric vehicles. Sustainable electric vehicles manufacturing. With this context, implementing sustainable manufacturing practices in Industry 5.0 significantly reduce the carbon footprint of electric vehicle production. Resilient supply chain in Industry 5.0 enhance the adaptability and efficiency of electric vehicles manufacturing in response to the global economy shift. So when we will come over this human machine collaboration and micro factory concept, the introduction of micro factory enable quicker market entry for new players in the electric vehicle industry, which supports lean manufacturing and flexible productions, sustainability and circular economy. And then digital product passports. Digital product passport enhance transparency and traceability throughout the battery life cycle, facilitating better life cycle management and compliances with sustainable standards. Advanced with context to advanced technology, we will talk about AI, machine learning, blockchain, and then with this context, what are the challenges and barriers? So, immature technology providers, one of the significant barrier to integrating Industry 5.0 in electric vehicles that battery manufacturing is immaturity of technology provider. These challenges need to be addressed to fully leverage the benefit of advanced technologies. And then data privacy and cybersecurity. The adoption of AI and other digital technology raises concerns about data privacy and cybersecurity, which need to be managed to ensure secure and reliable manufacturing process. Then another one interesting questions which we will talk. What are the potential advancement in electric vehicle technology due to Industry 5.0? So with this context, Industry 5.0 characterized by the integration of advanced technologies such as artificial intelligence, Internet of Things, and robotics is poised to bring significant advancement to electric vehicles technology. Here are some potentials. So with this context, electric vehicle technology, so energy management, then with context to energy management, thermal management, fleet operation, energy efficiency, and integration of with Industry 5.0. With this context, artificial intelligence and Internet of Things should be very important component, and advancement with this context, compact design, power electronics, battery technology should be there. So when we will come, the enhanced efficiency and sustainability, the smart charging, leveraging IoT, AI, and data analytics, Industry 5.0 can optimize e-vehicles charging infrastructure, aligning it with renewable energy goals. This can improve user experience, reduce cost, and enhance trust in electric vehicles by predicting energy uses and optimizing charging schedules. Integration with renewable energy, the integration of vehicle to grid and grid to vehicles technology can promote sustainable transportation by enabling electric vehicles to interact with power grids, thus supporting the use of renewable energy sources for charging. Advanced battery and energy management system. So battery advancement, Industry 5.0 technologies can drive innovation in battery materials and management system, enhancing energy storage, reducing charging time, and improving overall battery performance. Energy optimization. So AI and machine learning can optimize energy consumption and improve the efficiency of fuel cell in electric vehicle, extending driving range and fuel cell durability. Enhance efficiency and sustainability. This sustainable transportation model. Sustainable transportation model with this context, Industry 5.0 supports the development of sustainable transportation model by integrating economy, environmental, and social factors. This includes the adoption of electric passenger vehicles and the use of multi-criteria decision-making method to evaluate and benchmark sustainability sustainable approaches. Collaborative human-machine interaction, human-machine collaboration, Industry 5.0 emphasize collaboration between human and machine, which can lead to more personalized and efficient production process in electric vehicles manufacturing, ultimately improving product quality and customer satisfaction. With this context, future research direction, so emerging technology, future research in Industry 5.0 will likely focus on integration of AI, 5G, beyond 5G and 6G technologies, blockchain and quantum computing for future enhanced electric vehicle technology and addressing existing challenges. So even though this integration of AI, AI-driven predictive maintenance systems significantly reduce the operational cost of electric vehicles. Integrating of AI in electric vehicle energy management system can extend battery life and improve overall vehicle efficiency. And then this new things, advancement in wireless charging of electric vehicles. With the context of wireless charging technology for electric vehicle is gaining significant attraction as evidenced by the rising interest in this area. This technology promises to enhance the convenience of efficiency of e-vehicles, charging potential leading to the broader adoption. Research is focusing on dynamic wireless charging systems, solar power solution, and IoT-enabled charging infrastructure, which could revolutionize the e-vehicle charging landscape. So, dynamic wireless charging system can eliminate range anxiety and increase the adoption rate of electric vehicles. Integration of solar power wireless charging stations can make electric vehicle charging more sustainable and cost effective. So, another interesting point is fuel cell electric vehicles and hybrid systems. So, the development of fuel cell electric vehicles and hybrid system is a rising theme, reflecting the growing interest in alternative powertrains that complements battery electric vehicles. And then with this context, research exploring the integration of fuel cells and batteries and ultra capacitor aiming to enhance vehicles range efficiency and sustainability. This hybrid system combine fuel cells and battery can achieve higher energy efficiency and longer range compared to the traditional battery electric vehicles. The adoption of this hybrid system combining fuel cells can significantly reduce greenhouse and green emission in transportation sectors. When we will talk with context to IoT and the smart system in electric vehicles, the integration of IoT and the smart system in electric vehicles is a very novel concept, indicating emerging interest in leveraging connectivity and data analytics to enhance electric vehicle performance and user experience. Innovation includes IoT-enabled energy management, autonomous driving, features and advanced safety systems which could transform the electric vehicle ecosystems. And this IoT enabled energy management system can optimize charging schedule and reduce energy cost for electric vehicle owners. A smart system in electric vehicles can significantly improve safety and reduce the incidence of accident. Next, very important component, new energy vehicle market dynamics. So the dynamics of new energy vehicles market particularly in a region like Asia, Europe, and America, present a very interesting research which focus on market trends, adoption barrier, and technological innovations driving the new energy-based electric vehicle sector. Understanding these dynamics is a crucial for developing strategies to to accelerate the transition for sustainable transportation. So, with this context, government policy and incentives are the most significant driver of new energy vehicles adoption in emerging markets. And then technological innovation in battery and charging infrastructure will be the key to overcoming adoption barrier in new market. So next interesting questions: how does energy, Industry 5.0 influence the integration of smart technologies in electric vehicles? So with this context, when we will talk about the Industry 5.0 emphasizes the synergy between the advanced technologies and human-centric values, aiming to enhance sustainable development and efficiency in various sectors, including e-vehicles. This new industrial paradigm integrates technologies such as AI, machine learning, IoT, and digital twins to create smarter, more efficient manufacturing. And then this Industry 5.0 and smart technology in electric vehicles. So, with this context, smart technology that should be human-centric innovation in Industry 5.0. The consistent presence of human-centric innovation in Industry 5.0 highlights the ongoing integration of advanced technologies with human ingenuity, which focus the importance of human-machine collaboration, AI, IoT, in transforming manufacturing and other sectors, including electric vehicles. So, human-centric AI policy in Industry 5.0 will significantly enhance the efficiency, sustainability, and regular productions. This sustainable electric vehicle battery technology. So, Industry 5.0 innovation will lead to the development of more efficient and sustainable battery technology. Technological evolution with this context, the technological innovation in Industry 5.0 will drive significant growth in second-hand electric vehicle markets, enhancing sustainability. So, advanced supply chain technology in Industry 5.0 will optimize the distribution and sales of new energy vehicle, improving market efficiency. So, with this context, key factors are the with context to this electric vehicle, enhance manufacturing and maintenance, so digital twin and smart materials, that is very important. So digital twin, Industry 5.0 leverage digital twin technology to improve the maintenance and repair process of electric vehicles. Digital twin creates virtual replica of physical system, allowing for real-time monitoring and predictive maintenance, which reduce service time and cost. Smart materials, the use of smart materials in e-vehicles can significantly lower maintenance cost, by simplifying repairs and reducing the need for frequent replacement, sustainability and efficiency. So circular economy integration. Industry 5.0 promotes the circular economy by optimizing the remanufacturing process of lithium-ion batteries through technology like blockchain and IoT, enhancing sustainability and efficiency. Next one is energy management. So, AI-driven intelligent energy management system in electric vehicle contribute to the better power distribution and resource utilization, aligning with the goal of decentralization and decarbonization in energy networks. Human-centric design, so AI, machine learning, and personalized will be there. Integration with the smart infrastructure, so that's a smart in smart sustainable smart cities. Integration of electric vehicle with smart cities infrastructure supported by the industry 5.0 technologies can improve urban transportation efficiency and sustainability, including better traffic management and reduces environmental impacts. Challenges and barrier with this context. So, despite the promising benefits, the integration of Industry 5.0 technologies in electric vehicle sectors faces several challenges like immature technology providers, regulatory and cultural barriers, which I have discussed earlier. So, integration of smart technology with this context, Internet of Vehicles and Advanced Driver Assistance System, ADAS. That's very important. So, convergence of IOV, Internet of Vehicles, and Advanced Driver Assistance Systems is a rising theme reflecting the increasing interest in enhancing vehicular intelligence and connectivity, which also explores the integration of IOV and ADAS technology to improve vehicles' safety, traffic management, and overall driving experience. So, integration of IOV with ADAS technologies can significantly enhance vehicle safety and traffic management. Advanced communication network in IOV can improve the efficiency and reliability of ADAS systems. So the integration of smart technology in electric vehicles, Industry 5.0, that's manufacturing and industrial development, sustainability, energy efficiency, and circular economy, technology innovation, that's concerned with digital twin and IoT, challenges, that's power electronics and energy management. So with this context, integration of smart grid and electric vehicles, the integration of smart grid with electric vehicle is a consistent theme that can maintain consistently interest which focus on the challenges and solution related to the integration of electric vehicles into smart grid systems, including impact of power quality, stability, and the optimization of charging infrastructure. So this integration of smart grid with electric vehicle so can significantly enhance the efficiency and reliability of electric vehicle charging infrastructure, advances control strategy in smart grid, and mitigates the impact of high e-vehicles penetration on power quality. So smart charging technology of e-vehicles, smart with this context, this smart charging technology for e-vehicles continue to be a consistent theme, focusing on the advancement in charging methods, optimization strategy, and the impact on power grid, which also supports technological innovation and sustainable strategy required for e-vehicles adoption. Smart charging technology can optimize energy management and reduce the strain on power grid. It also concerned with innovative charging methods can significantly improve the efficiency and cost effectiveness of e-vehicle charging infrastructures. Next one is barrier to electric vehicle adoption. The barrier to electric vehicle adoption remain a consistent theme reflecting the ongoing challenges faced by the consumer and policymaker in promoting its uses, which encompasses various impediments such as technology, economy, and infrastructure barriers, as well as policy recommendations to facilitate seamless integration of e-vehicles into the transportation ecosystems. Targeted policy intervention can significantly reduce the barrier of EV adoption in emerging market. Technological advancement in battery management system can address key challenges in EV adoption. So blockchain integration with Internet of Vehicles. The integration of blockchain technology with Internet of Vehicles is a rising theme indicates growing interest in enhancing the security and efficiency of connected vehicles network, which provides secure communication, privacy protection, and performance optimization, highlighting its potential to revolutionize vehicular connectivity and autonomous driving. Blockchain technology can significantly improve the security and privacy of Internet of Vehicles network. Integration of blockchain with digital twin technology can enhance the efficiency and reliability of connected vehicle systems. And then now come over the key challenges in integrating smart technology into electric vehicles in the context of Industry 5.0. So integrating smart technology into electric vehicles within the framework of Industry 5.0 presents several significant challenges. These challenges span technical, economic, social, and regulatory domains, reflecting the complexity of this integration. So, come one by one. Technical challenges with context to Industry 5.0 and electric vehicle. So, energy management and interaction. Effective energy management is a crucial for integrating EV into a smart grid. Challenges include optimizing real-time energy management and vehicle-to-grid coordination using AI and predictive control techniques. Additionally, the difficulty in energy interaction and uh, need for advanced management software function are significant hurdles when we will talk about the energy management and interaction. Next one is repair and maintenance. The complexity of e-vehicles make repair and maintenance arduous and then costly. The use of digital twin technology and smart material can ease this process by reducing service time and cost. Next one is battery disposal and recovery. The environmental impact of lithium ion battery waste is a major concern. So Industry 5.0 technologies like digital product passport and digital twin can enhance transparency and life cycle management, adding in efficient battery remanufacturing. Next one, communication and data security, integrating 5G, beyond 5G and 6G and IoT for real-time communication and data processing is an essential but poses challenges related to the data security and network infrastructure. Then come over the economic challenges. Cost of smart technologies. The high cost of implementing advanced technologies such as AI and IoT and smart material can be a barrier. These technologies are essential for predictive maintenance and efficient energy management but require significant investment. So business model, developing new business model that integrate EV into the existing energy and transportation ecosystem is necessary. This includes creating value-added services and ensuring end-user acceptance. And next one is what we say, these social challenges, user acceptance. The range anxiety and availability of charging station are primary deterrent of EV adoption. Overcoming these barriers require enhancing the EV driving experience and providing reliable infrastructures. And then cultural barriers. The transition to smart technology in EV also faces cultural resistance, particularly in regions where traditional vehicles are deeply entrenched. Then regulatory challenges. Next one. With this context, standardization and regulation, that is very important. The lack of standardization is standardized communication protocols and regulatory inertia in V2G and G2V. Market participation are significant obstacle. Unified privacy preserving data architecture and clear regulatory framework are needed to facilitate integration. And then next one, sustainability goal. The aligning the integration of EV with broader sustainability goal require a holistic approach that consider environmental, social, and economic impact. So next, we try to conclude it with the conclusion. The Industry 5.0 offer transformative potential for EV sector by fostering human-machine collaboration, advancing manufacturing techniques, optimizing battery management, and enhancing supply chain process. These advancements contribute to more sustainable and efficient EV industry, aligning with broader environmental and economic goals. However, addressing these existing challenges is essential for realizing the full benefits of Industry 5.0 in this sector. So Industry 5.0 is revolutionizing the manufacturing process of electric vehicles by enhancing efficiency, customization, and sustainability through advanced technologies and human machine collaboration. While there are challenges to overcome, the integration of AI, blockchain, and other Industry 5.0 technologies holding significant potential for transforming EV manufacturing landscape. So Industry 5.0 is a set to revolutionize electric vehicles technology by enhancing efficiency, sustainability, and user experience through the integration of advanced technology and smart systems. So Industry 5.0 significantly influenced the integration of smart technology in the electric vehicle by enhancing manufacturing process. How you are overcoming the technological, regulatory, and cultural barrier is a crucial for the successful implementation of these innovations. So integration of smart technology in EV with Industry 5.0 is multifaceted. challenges involving technical, economical, social, and regulatory dimensions. Addressing these challenges require coordinated efforts from policymakers, industry, stakeholders, and researchers to develop innovative solutions and framework that support sustainable and efficient EV ecosystems. So now, thank you so much for bearing me, saving humanity with you. Thank you so much.
Thank you so much, sir. Thank you.
It
Thanks
was
a lot, sir, for such an informative session on
thank you
impact
so
of
much.
Industry 5 for this EVs and related technologies. Thanks a lot, sir. I hope that our participants would have enjoyed this and it would be helpful to them for their research. So, sir, we do
Yeah,
have
definitely.
some
Yeah,
questions
definitely.
and from participants. So I will allow them one by one to ask their questions. So first one is from Beamsen Tudu. Let me. So Beamsen Tudu, please turn on your mic and you can ask the question. Hello, Beamsen Tudu.
I think, sir, he has already asked the question in the question answer box.
Okay, just let me see
Okay,
this
sir. The
chat.
question is that with the rise of Industry 5.0 in EV, what new skill sets will be most important for the future workforce?
Uh, Sir,
So
it is
can I repeat the question?
yes, but in tools and bus.
Actually, with this context, e-vehicles, it is not a single sector like a electrical engineering, electrical, electronics, and communication engineering. In addition to this one, this our mechanical, material science, as well as what we say, a general way we can define a system engineering, right? And this one, so various components. Suppose when we will talk about with context to energy management, right? Battery. So with this context, we deal another way, and other components we deal another way. So for this one, tools, suppose for this battery management, how we should develop, particularly now we are switching from wireless charging, right? And how efficient, how fast it should charge. So with this context, we have to switch. Okay.
There is no reply from Beamsen Tudu. I hope Ghanshyam sir has answered your question, Beamsen Tudu sir. So next question is from Burla Sridhar. And the question is that new vehicle technology with hydrogen as a fuel in Industry 5.0 in advancement. How you can
Yeah,
see this
actually,
in replacing?
this one,
So how,
hydrogen fuel, it's a very emerging technology, and it is very useful. Even one of my in our faculty, that's mechanical engineering, one team is working on this hydrogen fuels. That is very emerging technology, right? And it should involve, then our energy efficiency will drastically enhance. That's very interesting.
answer question is that how you can see this in replacing lithium ion battery for EV technology?
Actually, with this context, lithium ion battery, this, as I discussed, it's a sustainability concern, where to dispose. right? This is a major concern. That is not compatible with our sustainability and fulfill the criteria of environmental sustainability. That is a major concern with context to lithium ion battery. It's a okay, interesting. It can be, but better to move on renewable energy, wireless charging.
So,
With
sir,
this,
next question is from Vijeta Kilam Seti. And the question is, any challenges faced during EV repair processes? And how can smart materials help address them?
yeah, smart material will be very useful. And then with context to repair, when this one will come in the market and lot of in use, then definitely this repair system will be there, and then it will be costly when it's a production, mass production come in the market. Then definitely their cost and repair cost are all should be reduced, but is still in initial stage it should be costly. Okay.
So, Bhimsen Tudu has raised his hand. So, you having
Yeah,
any
please.
question, Bhimsen Tudu?
Hello, sir.
Yeah.
Good evening. Sir, I am Vincent from the Wall Street Center, Bhubaneswar. I have the same question because we have been training the student for the uh, skill sectors, right?
Yeah,
So
right.
the
Very
what
interesting.
skill sectors, uh, the advanced skills. So what skill set the students should require in the rise of the industry 5.0 in the especially in the EV segments?
Actually, this is very interesting. Skill sector with this context, hands-on. That is very important, and each cases they do with their hands-on. And skill for them, skill any criteria is not important. We have to train them,
Okay,
right?
yeah.
In the skill sector, it is very important to hands-on. That's very important. And whatever the any skill, just it's a target to train them, right?
Okay, sir. Okay, thank you.
So, sir, there is one question from engineer Manish Kumar. The question is,
Yeah.
why Ola scooter has long waiting in repairing? Is there any technical reason for that or anything else?
Hello.
Hello, sir. There is one question from engineer Manish Kumar,
Yeah.
and the question is, why Ola scooter has long waiting in repairing?
Waiting,
Is
I
there any
think.
technique?
Yeah,
Is there any
maybe.
technical?
I don't know exactly specific manufacturer, but maybe their availability or components, that's issue. I don't know exactly the specific sector, right? What exactly region they with that context?
Okay, so sir, there is one last question, and the
Yeah,
question is from
please.
Dr. Kiran Kumar.
Yeah.
Question is, sir, is the EV industry growing, and what are the key success factors in EV industry?
Actually, for this key success factor for EV industry is our emerging technologies. That are the key factors, right? This AI, machine learning, Internet of everything's, communication technology, right? So these are the key factor for them. And even this our emerging materials, smart materials, so these are the key factors with that context, and every sectors play very significant role. Because of that one, I'm talking when even though with our coming generation, as he is talking about his skills. So when this sector, what we say, system engineering, so that should be very useful. right? So emerging technologies, that is very important with yeah, that's a key component for this EV sector.
So there is one question from Satyajit Sahu. Satyajit Sahu, please turn on your mic and
Hello, sir. Good evening. Thank you for giving me this opportunity to ask. Sir,
Thank
it
you.
is a generic question from like a layman's point of view. Like all the users who are using EV always have this in the back of the mind that there is a chance that sometime our vehicle may break down or there may be a short circuit inside. Like I see a lot of news coming out every day in day out that some of the EV has caught fire, or maybe there is a short circuit in the circuit and there is a big mishap. Like recently today only there was a fire in the EV factory where 30 EVs got burnt in Odisha. You can check it today, sir. So does industry 5.0 or like any data driven method give an alert of this to the customer or maybe to the user end? Like we can use any data set to analyze or predict anything, like a mishap is coming, or any short circuit or a overheating is there, so that from that data analysis we can check that whether this EV is nearing a fault. Please.
Yeah, actually, this one in the presentation, as I discussed, when we should involve the emerging technologies like AI, machine learning, so definitely it will predict predictive maintenance, right? It will provides whatever the data available on the basis of it should provides what happening next, right? So this one, whatever the phenomena we are facing with this industry, just it is a initial stage. When this technology, all these technology will mature and implemented uh, successfully, then all these problems will never face. Actually, with this because of this industry 5.0, main purpose of this one, safety of our workers, right? It is a initial stage, even though uh, many industries, they are even working on their conventional approach. They are not implementing new technologies. So new technologies that should be useful for our workers. Even this concept of industry 5.0 is for safety of our workers, right? Suppose when we will talk about human robots collaboration, so some places where a human can't go, then robot will go and solve the problems, right? So it is still now we are not in a mature position. Just it's a initial stage, so we are facing these problems. Is it okay?
Yes, sir, I got my answer. But I guess still, I guess the end user has to be trained properly, or the end user has to be alert about this predictive maintenance and all these things. Because I've seen a lot of my friends, they use there is a alert like service due after this time, and you must service your EV between that time period. But
Yes.
often people or the end user, they ignore these type of alerts and they continue using their EV.
Yeah,
So
actually,
even
with
if
this
we,
context,
yes, sir.
it is very interesting, and in new vehicles, it is going to implement, right? It will alert you one times, two times, three times, and if you are not doing that one, their maintenance, then it will block, right? So new coming vehicles, these type of technology is going to implement. They will alert one times, two times, and three times, and then after that, if you are not taking care, then your vehicle will block.
Yes, sir. That would be a very good like implementation. Like if the vehicle is automatically stalled, then the person who is end user has to do the maintenance. Otherwise, they cannot move ahead. That is a good
Right.
implementation, sir.
Yeah, yeah. Actually,
Thank you.
because of this emerging technology, uh, is going to implement in all these directions. Major concern is our safety. Every day, a lot of people are dying with our accidents. Is it? So this safety is a major concern. Even though when we are talking about Internet of Vehicles, right? It is very important when we should implement, and then how safety our safety will improve.
Thank you very
Because
much,
of
sir.
that, emerging technology has been involved.
Yes, sir. That is like good implementation of Industry 4.0 for
Yeah.
social welfare. Thank you,
Right,
sir.
right. Thank you. Okay. Thank you.
Thanks a lot, sir, for such fruitful sessions. Now, I would like to invite our HOD, Sir Dr. Kumud Ranjan Jha, to please conclude this session, today's session of FDP.
Okay. Thank you.
Okay, thank you. Before showing the gratitude to our speakers, I have a few things to say to the audience. Basically, I was also listening to the presentation, and regarding the skill set, people were stressing upon the skill set. Just I will add on to what Sir has told, that we are this particular the electrical vehicle. It is the interdisciplinary system. What the sir has told, in addition to, I will suggest you that even the CAD simulation, which is not the pie, which is not the share of the pie, okay, our pie means for the electrical engineers, that is also the part of the electrical vehicles analysis and simulation, CAD simulation, which normally we used to think that it is a part of the mechanical engineering or some similarly the batteries, which is the part of the energy management or the energy engineering. So the skill set, when we talk about from the electrical engineering perspective, we are thinking about the power electronics. We will be working on the power electronics. We should have the skill of the power electronics, control systems, then the electrical circuits and all. But we have to think about the other things which we are normally not covering. So we have to expand the horizon of our skill set to materialize the concept of the electrical vehicles. So I hope that this addition makes sense to all of my audience, that which we are discussing about the skill sets, isn't it? And now I will say thanks to my all my teacher as well as the speaker of the day today, Professor Ghanshyam Singh sir. He has taken a lot of pain in developing this valuable presentation and sparing his busy schedule, out of the busy schedule, for on the short invitation of our institutions and our request. And as well as I am also thankful to my friend Dr. Viranja, who has delivered the talk in the first session. And with this, if there is nothing else, then I will request to conclude the session also. So, is it okay?
So thank you, Professor Kumud Ranjan and Soni, for inviting me. It's an interesting interaction. So after long time.
Okay. Okay.
Thank you, Jha,
Thank
sir.
you so much, sir. Thank you.
Thank you, Professor Jha.
Thank
Okay.
you.
Okay.
Okay.
Thank you so much.
So we are here now. We are concluding the session. So dear participants, thank you so much for listening these sessions with the patient. And hereby we are concluding these sessions. We will meet tomorrow for next sessions. So thank you so much and good night. Thank you.
Okay. Good.
Thank you, sir. Thank you.
Okay.